So this is our last section, part 6, before we start reviewing and getting ready for the quiz and test or whatever we do. So we're still using our reciprocal identities, which are all of these. We are still using the quotient identities and Pythagorean identities, but now we're to introduce the confunction identities. They look a little scary, but honestly they're super easy. And the even and odd identities. And I want to point out that all of these are odd identities, and these are the only two even identities. So again, we're type 6, where there's the confunction and the even and odd identities. Pretty straightforward. And we're just going to use them and simplify the equation just like we were doing part 1 through 5. Our first function is that we had to simplify is the cosine of negative theta times the secant of negative theta. If you look at your confunction identities, you'll see that the cosine of negative theta actually just becomes cosine theta, and the secant of negative theta becomes times secant theta. And what's going to happen is we're going to leave our cosine, but we are going to take the reciprocal or the reciprocal identity of secant theta, and that's going to be 1 over cosine theta. And now we could reduce these, and now we get 1, and now we have verified our identity. You guys try this one out by yourself. So if you were absent, pause this and then try it by yourself, and then unpause to check your answer. So we know that cosecant of negative theta becomes negative cosecant theta. Tangent becomes negative tangent theta because these are odd functions. Since we want secant of theta, we're going to change the negative cosecant to its reciprocal. So we know that that's going to be 1 over sine theta, which is going to be the negative. And we are going to change tangent into also use its quotient identity, which is going to be negative sine theta over cosine theta, because we want secant. So that means that we know that the reciprocal of secant is 1 over cosine. So these are going to go away, and these two negatives are going to become positives. So we're going to have 1 over cosine of theta, and that becomes secant theta, which is now we verified it. You also did this one by yourself in class, and it was straightforward. This becomes negative sine of theta because it's one of the odd functions. This becomes positive because that's one of the even functions, and we know that the sine theta over cosine theta is a quotient, which that negative makes it negative tangent of theta, and we have verified. So for this one, if you notice, these are not the even and odd, these are the confunction functions. So we have that one and we have this one. So we know that the top function sine of pi over 2 minus x is one of the confunction formulas or identities. And we know that that one equals cosine of x. And we know that cosine pi over 2 minus x is going to be sine of x. And we know that cosine of x over sine of x is a quotient, and which equals cotangent of x. So now we have verified. Pretty straightforward. Again, this one's not that hard. I want you to notice that this is a conjugate function. After we use our identities to change these negative cosine thetas, so that would be just regular positive cosine theta, which gives just cosine theta. And since it's a conjugate, we know we could go the first times the first, the last times the last, because the two middle terms will actually cancel out. So we have 1 times 1 is 1. Cosine theta minus cosine theta is negative cosine squared theta. And we know that this is a Pythagorean identity. And I'm abbreviating here, which that actually is equivalent to sine squared theta, which we just verified. Okay, so same thing. We're gonna use our things and transform it. We know that cotangent of pi over 2 minus x is the same thing as tangent of x. So we're going to have tangent of x there plus, and we know that tangent would turn into cotangent of x. And we have sine, that becomes negative sine. And cosine becomes positive cosine. I'm going to suggest turning the top part into all sines and cosines. So we're going to have, we know that tangent is the same thing as sine of x. Cosine of x plus cotangent is cosine of x, sine of x. All of that over negative sine, cosine of x. On the top part, we need to get a common denominator because we have a plus sign right here. So we're going to multiply this side by sine of x, this side by cosine of x. And we're going to get at the top, we're going to have sine squared of x plus cosine squared of x. All of that over cosine of x, sine of x. And you know what? Let me already take the reciprocal of the bottom ones just so we have a little bit less steps here. So I'm going to take the reciprocal of the bottom. So we're going to have negative cosine of x over sine of x. And now we're going to use our identities to either reduce things or change them. Well, we know that this is a Pythagorean identity and it equals 1. So we're going to have 1 right there. These cosines are going to reduce. So we're going to have a negative 1 on the top. And at the bottom, we're going to have 2 signs left over. So that should be sine squared of x. And we know that negative 1 over sine squared of x is the same thing as cosecant because they're reciprocal identities. So now we have verified it. The last thing we want to cover is sometimes when you have conjugates and you need, the other side looks a little different. I want you to understand that if you see a conjugate, one good idea to do is maybe multiply by its conjugate. And if you have something like this one right here, the conjugate of that would be this, and you multiplying by its conjugate might help you get to your end purpose or your verification. So we have this example right here. I want you to notice that this piece right here, the conjugate of this is in the denominator, and sine and cosine are changed. So I suggest, I'm not saying it always will help, but it might help a lot if you multiply by its conjugate, top and bottom. So I'm going to multiply the middle by its conjugate, which is 1 minus cosine of x. And that means on the top, I'm going to get 1 minus cosine of x times 1 plus cosine of x. On the denominator, I'm going to get sine of x over 1 minus cosine of x, which that means I have a 1 minus cosine of x here and here down here, which is what I wanted. Since it's a conjugate, we know that we're going to multiply the first times the first, the last times the last, because the middle terms will cancel. We're going to have 1 minus cosine squared of x all over sine of x, 1 minus cosine of x. And we know that this top part right here is a part of a Pythagorean identity, and we know that this piece on the top is equal to sine squared of x over sine of x, 1 minus cosine of x. And then we could actually reduce the 1 on the bottom and 1 on the one on top. And now we're going to get sine of x on the top and 1 minus cosine of x on the bottom, which is what we wanted, and we have verified.